Greetings. My name is Matthew Kidder. I'm a PhD economist. I got my PhD from the University of California in Irvine, and I do data science work. And I'm currently in higher education at a teaching institute up here, specifically at Newberry College. And what my goal here is to try and bring data sciences and programming and develop it in the local area. So I've been doing that in higher education, and in my experience here, I've quickly found out that what that there's some sort of basic types of skills that are lacking in the local population in terms of just programming skills, computer programming skills, specifically in object-oriented programming. So programs like C++, programs like Python. Okay, they're so I've come across, and I'm not speaking to every single school, but I have seen actually that there are quite a big deficiency that I'd like to try and help to address. And so how to do that is, first off, I'd like to just introduce you to some sort of open curricular resources that can help you to very quickly and easily just roll out some types of programming in the classroom. Super easy, and you don't have to be a PhD economist or a data scientist to do these kind of things. That's the coolest thing, is it's actually super straightforward. And what I'd like to offer is just I'd like to help to get this implemented as broadly as I possibly can. That's my mission here. Okay, I just be very upfront. My mission is to get as many kids sort of exposed to programming in a fun sort of programming in a project oriented kind of a setting. That's a key, project oriented. So getting kids to actually work on things and create things and do things. And how to do that? Well, guess what? There's actually a lot of resources. And so that's what I'm here to show you today. I'm here to show you some resources of some types of open, just very open type of resources that can be implemented. So Amazon has a Future Engineer program for elementary school students, and they also have it actually all the way through. So there's nice continuity there. What my goal here is to try to find. I'd like to start at the very lowest levels. So maybe I'm thinking first, second grades, and then just try to roll something out to start there, and keep rolling this out. So so the let's just dive into it. Okay, let's just dive into it. Best thing is just to see it. So here we go. So here's the type of projects that kids can actually create, and you can actually help create them very easily. And I'll show it to you just here today. But these are all games, and you see that they have different. So when you see games like all kinds of games, there's AI. So AI, even AI types of concepts we can teach kids. They can also teach them just basic programming. Um, so what I can help do is also help to help sort of pick some games that I know will be sort of easier to get for younger kids, and also cover some of the scopes. And I can also help to help you to teach some of these concepts too. I'm very happy to help do that, just in terms of helping you to understand maybe what some of the key learning objectives actually are. And so part of that. So you'll see uh, when I click on a game, they actually have teachers' notes. So that's very nice. That's a nice resource. You can read about the game. You can talks about prerequisites, introductions. Um, you see all these different types of notes. There's just specifically for teachers. And so there's that. That's a great resource right there. I will say there's 22 pages of this. I'm not going to go through all 22 pages here, but this really goes through a lot of the details, and they've done an excellent job in that sense. So they've created a game that kids can start coding. They've given teachers resources, and this is all open and free. Now, this is the game that we'll actually be creating, and the game's just a dinosaur that runs and jumps over cactuses and collects coins. Okay, there's a lot of different games, but and that's what I think is kind of fun, is that eventually you show kids these how to learn these things, and they can become maybe even self-learners. That might be an objective in itself, and then the sky's the limit for where they go. But you can watch the game, dinosaur collecting coins. Okay, so let's go ahead and start coding. Okay, and here we go. This is the code. I'll take my face away from the. Here's our game. This is the testing environment, and kids actually program with what they call blocks. They're just code blocks. Now, every one of these blocks actually has sort of a real code, sort of what do you call it? There is a parallel to these blocks in real programming. So, and this is where I can maybe help bridge some of these gaps. But you see, when play button is clicked, there's the play button, then it'll say do something in here. Okay, this is a sort of a conditional type of logical statement. So we want to move the dyno forward. Okay, so move dyno forward, play some music. Okay, you can play some music, Mario theme, whatever you want to choose. Okay, and let's go ahead and play. Okay, yay, I got to step two. So you'll see it's sort of sequential. It'll bring you through actually creating this game. So the nice thing is that they've got instructions up here, and so depending on how sort of advanced your students are in terms of reading, and this can also be a type of learning objective itself, is like reading instructions, following directions, and like actually implementing that. And you might stop and pause and help them to learn how to just repeat. So it says repeat blocks are used to perform a set of activities again and again. Use the forever to make Dyno continuously move forward while you play the game. So this is what's called kind of a loop. So we're going to bring the loop in here. So when it's clicked, then forever move Dyno forward. Okay. You see, so of course, like when you're teaching this, you would want to lead the students to discover these kind of on their own versus just telling them, obviously. Um, Dyno moves forward forever. And you can keep on developing these, okay? So the next one, it says, and they also have a video for this step. So you can watch a guide video. But you can also I would probably have the students read it. So make the Dyno jump up when you press the space key on your keyboard. That's what we want to do, make him jump up. So it says place the Dyno jump inside the when space key pressed. So here's when space key pressed, the Dyno jumps. Okay. And you see how this goes? This is very straightforward. Very simple. I'm not going to go through all the steps here, but progressively we go through, and you have to learn how to keep score, and you can also modify these games in a lot of different ways. So you eventually you'll have all these different types of code blocks available to you, and you can actually create other types of characteristics and get some creativity. Not just recreate what they want you to recreate, but you can actually recreate or create your own type of game. For example, I made a game where every time the Dyno, and I played this one, every time the Dyno touches a coin, the sky changes a color, and you can have the music change, or you could just play with it. And actually having them to get to that kind of creative level as sort of an ultimate, I think, ultimate goal is just to get them to be able to create with the blocks that they have. But these blocks, and actually doing code blocks in this way, what I like about it is that they're very straightforward tutorials. They walk you through sort of step by step, and they reinforce very key kind of programming concepts that are very much used in real programming languages. And so this is a primer that helps students really get ready for future, more serious types of object-oriented programming. It also teaches logic. It also teaches how to follow directions, reading and follow directions. It has a lot of different types of learning objectives, some of which I'm sure you can also think of others that you can sort of bake into these type of activities. But the cool thing is, again, is that these activities are numerous. For one, they're free. For two, and they cover a lot of. So you can also do. I did this morning. Is actually create an AI. So they have some types of AI concepts, artificial intelligence concepts. There are a lot of different types of programming concepts that are going to expose students to these concepts in sort of a fun, creative way. And I think that's the key thing. And so I really would like to try to help maybe bring this to the classroom. For my thought is maybe have them learn how to make one or maybe two games. Okay, just like a very, I think this is supposed to be for 1 hour. So these are, if you read, these are an hour of code. So it's possible to walk through these in an hour. Realistically, though, you may run into some bumps, or you may slow down, or there may be some glitches. So instead of trying to do one in an hour, you might say, okay, well, we'll try one in an hour, but maybe think about having it spill over into maybe 2 classes. So, um, but I think you can definitely do it in 1 hour, but maybe you split it up. I don't know. It just depends. I'd say always, I mean, I'm probably preaching to the choir, but let your students be the guide. Okay. So let them sort of guide you as far as, how far to go and what to do. And but there are a ton of resources and a ton of games. And the cool thing, like I said, is once students can actually learn how to read those directions themselves and follow those directions, and once you get them kind of turned on to it, they can just kind of jump around and play a lot of different things. And that's the cool thing about all this, is that it just opens the door to a lot of creativity that suits. You see, there's a lot of different domains. They've got dogs and underwater AI oceans and all types of different programs for all kinds of different interests. And I think this is a great start. So, and you see this goes all the way up to just multiple grades just with this one site. Now, there's also a lot of other sites that have other type of materials. We'll just stop here though, and that's it. I just wanted to give you an introduction. I hope that we get a chance to talk. I hope we get a chance to, like I said, I'd like to try to help to roll this out and make this available to your students. So anyway, please do feel free to reach out to me anytime. My name again is Matthew Kidder. That's Kidder, and you can actually find me directly on LinkedIn, Matthew Kidder. That will be my tag is Dr. Kidder from LinkedIn. Okay, so or you can find me at Newberry College, matthew.kidder@newberry.edu. Okay, so anyway, thank you so much for just taking this time. And again, I really hope that we can roll these things out. You will see if you read my LinkedIn profile that one of my missions is actually to help aid economic development. So I came across my PhD in that kind of a context in terms of studying development, and I'm very much, very, very much excited about trying to develop our local talent base right from the get go. That's where it all starts. Okay, it all starts with you. It all starts in your class. It all starts with those children who are in that first and second grade, and then we can kind of cultivate them throughout their life, and hopefully by the end, when they come out of high school, some, not all, of course, but some will develop an interest, and that's what we can best hope for, is that we get some that actually get turned on to a prospect of a very highly paid, highly rewarding career in programming. So if you follow, the starting salaries are extremely good in the industry, and it's where everything's going. So anyway, I'd like to help us all get there. And thank you very much. I'm talking too much now, so I'll say bye. And please reach out if I can be of any assistance.